Alright, I have a subtraction. I'm subtracting this polynomial. So what do I have to do if it's a subtraction? I learned that yesterday. Step here. Yeah, convert it, but can you be more specific? Change this to a plus, and then this? Yeah. And then this? Good. Okay, so change the sign. If it's positive, change it to negative. If it's negative, change it to positive. So now both of these terms are negative. So now I can group my like terms. So the A's and the A's can go together. 3/5 A, take away 1/5 A. What do you get? 2/5A. That's right. So it's just adding, subtracting fractions. Okay, and then now the B. So negative a half B, negative a half B. Kevin? Oh, your hand wasn't up. Sorry. Yep, severe. Yeah. A negative a half, take away another half, you get negative 1b. Okay, do I need to put this 1 here? No. You could just put negative b, negative 1b, same thing. Yep. Why are we subtracting it? Because this originally was a minus. So from yesterday, when we have a minus another bracket of polynomial, we have to change the sign. Change the sign to plus, and then everything inside changes sign. So now you have actually two negative a half, take away another half. Okay, so and then that's it. That's my answer. I cannot simplify it anymore because this is an A term, this is a B term. They're not like terms. Okay, this one, a harder one. Okay, so which two terms? Oh, actually, this one and this one. These two can go together. But what's wrong? Matthews? Sorry? Isabel? Denominators are not the same. So if you think back to chapter 1, you need lowest common denominator to add and subtract them. So in this case, 12. Okay, so 12 w squared over 12 w squared. Okay, so 4 times 3 gives you the 12. So 3 times 3 gives you 9. 3 times 4 gives you 12. So 2 times 4 is 8. So this is equivalent to this. So I just multiplied this whole thing by 3. I multiplied this whole thing by 4 so that I get the same denominator. Okay, same thing here. What about the w's? My two w's right here. What's my denominator here? 4, yeah. So put this over 4, put this over 4. So a half is the same as 2 over 4. And 3/4, it's already over 4. So I just leave that. And then the plus 8 at the end. Okay, so these two I can add and subtract together. So what do I get here with these two terms? Yep. 1 over 12. What? W squared, good. And then what about these two? Negative 1 over 4 W, good. And then plus 8. Can I do any more? Nope, that's it. Okay. So remember, after you get a lowest common denominator, you only add or subtract the top. Okay. If it's positive, it's plus. If it's negative, it's a minus in between to link them together. What do we call this type of polynomial again? Yep, trinomial. What's the degree of this? Matthews? 2, degree 2. What's my constant? Yep, 8. What's my coefficient in the first term? Coefficient in the first term. First term meaning this one. coefficient. What's my coefficient? Ivy? 1 over 12. Okay. It could be a fraction. It doesn't have to be a whole number. What about my coefficient in the second term? Maria? Negative 1 over 4. Good. Okay, so a quick little recap as well. So now, yesterday we did adding, subtracting polynomials. Guess what we're doing today? Multiplying. Okay, and today I'll explain why why you have to change the sign and everything in the bracket when you subtract. Okay, so multiplying polynomials. You need to know this term, distributive property. They asked that in EQAO. I could ask that on the test. It's how we multiply polynomials is by using the distributive property. So when multiplying a monomial and a polynomial distribution, let us multiply the term in the monomial to every term inside the polynomial. So for example, right here, notice there's no space between that, like they are side by side. It means multiplication. So I have to multiply that 2x to the 5x squared, and I have to multiply that 2x to the 7. So each time I'm multiply. Okay? When you multiply, I get 10. Where did the x cubed come from? How do I get x cubed? Yep. Because you multiply the x. Because you multiply the x. Remember before the break, the exponent rule? When you multiply, you add the exponent. So you get the 3. Okay, and then here, 2x times 7, you get the 14x. Okay. Another word that we use for distributive property is expanding. So it's the same thing. When we when you expand, you get rid of the brackets. Okay, so let's try this one then. You have 4 times x plus 2. Oops. Okay, Isabel. Yeah, that's it. Okay, there. All right, so multiply that 4 to everything inside the bracket. Okay, multiply. So 4 times x is 4x. 4 times 2 is 8, positive 8, so plus 8. All right, am I done? Yeah. Yeah, because I cannot group them anymore. These are, this is a variable term, this is a constant, so I can't group them anymore. That's it. Okay, what about this one? Again, I'm multiplying. So 3u times 15. Yeah, Isabel? 45u. And then what about 3u times negative 4u? Negative 12u squared. Good job. Okay. U times u gives you u squared because you add the exponents. 1 plus the 1 gives you the 2. Okay. And then example 3 here. Okay. This is a negative 3y squared, so be careful. Okay. Leanne? Negative 24y plus 21y. Good job. Okay, so negative 24 y squared times y, you add the exponents, so you get y cubed. And then negative 3 times negative 7, you get positive 21. All right, so be very careful with your sign. Okay. Okay, let me add in one more on the bottom. So one that we did yesterday. So for example, 4x plus 5y minus 2x minus 8, for example. All right. For example, something like this. Okay, how does this relate to what we did in today's lesson? Hi, Annie. Okay. How does this question from yesterday relate to today's multiplying polynomial? Yeah. Yeah. What is the number right here? Like, there's actually a number. Miriam? 1. So if I have a -1 here, then based on what we know today, we're multiplying that -1 in to everything in the bracket. So if I were to rewrite this, I get 4x plus 5, 5y, -1 times 2x, -2x. -1 times 8, sorry, -1 times -8, I get plus 8. So you see how I changed the sign and everything in the second bracket. All right, so, and then now I just group my like terms. So 4x minus 2x, I get 2x plus 5y plus 8. Okay, so that's why yesterday when we were subtracting polynomials, we had to change the sign and everything in the second bracket. That's because the distributive property tells us to multiply that -1 in. Okay, so everything tying in together. Okay, on the back. So we're doing really well. Okay. What about this one? Miriam? Okay. 55z to the power of 3. Okay. Am I done? Again? Yeah, they're actually like terms. Right. This is a z cube, this is a z cube. So I can actually add them together and get 60z cube. Anybody do it a different way? Did anybody do this a different way and got the same answer? Well, if you think back to bed math, what are we supposed to do first? Yeah, if you look inside this bracket, z plus 11z, can I combine these two? Yeah, it becomes 12z. So I could have also did this, 5z squared times 12z. And what do you get? 60z cubed. Yeah. So in this case, it works. Like both way works because you are multiplying to both terms. It's the same as adding the simplifying the inside first and then multiplying. Both way works. Both way you get the same answer. Okay, but normally you want to follow BEDMAS first. So do the brackets first and then multiplication. Okay. Just 2 more examples. Fill in the missing term to make the expression true. So what goes here in this box? Miriam? 3x to the power of 2. So let's see. Let's see if she's right. Okay. So if it is 3x to the power of 2, when you multiply and multiply, you get 15x cubed minus 21x squared, which is the same thing. Okay. So yep, you can do that. Another way you can do it as well is, this is another way, you can divide. Divide the first 2 terms. Right? When you divide 15 divided by 5, you get 3. X cubed divided by x, you subtract the exponents, so you get x squared. So 3x squared. Okay. If you do the same thing for these two terms, the last two terms, you should get the same answer. If you don't get the same answer, it means you made a mistake. Okay. Any questions so far? Am I going too fast or okay? Okay. Okay, last one. Find the area of the shape. Actually, I'm going to add in the perimeter as well. And perimeter. So find both. So find both perimeter and area. Nice. So area of a rectangle. How do you calculate the area of a rectangle? What's the formula? Length times width. Okay. So what times what? So again? 4j times 5j plus 12. Times 5j plus 12. Okay. Can I write it like this? I have to put brackets around the 5j plus 12. If I don't put brackets around this, the 12 is not going to get multiplied by the 4j. So I could write it like this. I could write it like, I could write it like this. Since length times width, doesn't matter which you call length, which you call width. I could write it like this, or I could write it like this. Okay. Which way is the easiest to read? Yep. The third one, right? Because we know to use the distributive rule. So I personally, I like this way the most. But why I wrote it these two as well? To show you guys it's the exact same thing. So if you see a times a binomial, you know to multiply it to everything in. Same thing right here. Even if you have a binomial times a monomial, you do the same thing. You would do the 4j times that. Okay. So notice they're the same, but written differently. All right, so then I get 20j squared plus 48j. Okay, and that's it. I cannot simplify it anymore. Okay. Perimeter. What's the formula for perimeter of a rectangle? Matthew? Yeah, length plus width. Or you can do 2 times length plus 2 times width. That's the same thing. Doesn't matter. So 4j plus 4j plus 5j plus 12 plus 5j plus 12. Doesn't matter which one you call length, which one you call width. Okay, and what does this simplify to? We learned this yesterday. Yep. Sorry? That is okay. So group 8. More. So group all the j's together. 4j plus 4j plus 5j plus 5j. 18 what? J. And then the constants. 12 plus a 12. 24. Okay. Okay, so that's it. I want you guys to try these questions And then same thing tomorrow, I'll give you guys, like at the beginning of class, I'll give you guys a challenge question to see. Like try maybe one that involves expanding and simplifying, multi-step one. Okay. Where do you think I can find these questions? Right space. That's right. So go to our right space page, and then content. Chapter 3, Part 2, Polynomial. And today's lesson, multiply polynomial. This one. Okay. And you will see the questions on page 3. Okay, so number 6, 7, 8, 9, and then 11 and 12. So starting here, number 6. All right. Answers are on the last page for you to check your answer. So not to copy your answer, check your answer. Okay, any question on today's lessons? Listen. Okay, so try these homework questions now. If you finish, you finish. If you don't, you have homework.